gonna share mine. There we go. Hey, I think I'm gonna get started. So I just want to say welcome, everyone. Thank you for coming. This is now our last day of the software carpentry workshop. So we will be continuing on our third day with R. Um, if you have any questions during the course of the day, you can always raise your hand and I can try and answer. And we've also got Rehema here with us. I don't see Takudzwa yet. So you can also send questions to Rehema and when he arrives, Takudzwa. Um, right. So yesterday we looked at mainly functions, so how we can define them and call them, and we did some exercises on that, and we also did for loops, so looping. So one of the important things that we're going to continue with is our analyze function. So at the end of yesterday, we wrote a for loop that would go through all the different files in our data folder with information .csv. And what it would do is it would plot all of those uh, files, the average, minimum, and maximum information daily. So I'm just gonna rerun the analyze function, make sure that we've got that in our memory, and then the line where we used our list.files built-in function, where we used our regular expressions to get the CSV files that we were wanting. And finally, we used our for loop to go through each of the file names that we got from this list.files function. Right. So at the end of all that, we had our plots, 3 plots per CSV file. So now we're going to create a function called analyze all, which is going to be very similar to what we sort of have here where we use our for loop, but we're just going to put it in a function so it becomes a bit easier to get the file names and run the for loop inside our function that we can then call each time. So analyze all is a function. So we have our keyword function, and we are going to take in our folder name. So we know that for us, it is data. So I'm going to default that our folder name is going to be called data. So one of the arguments is folder, and our second argument we're going to say is pattern. So in this case, we're giving two arguments, folder, so that we know which folder to look in, and pattern as giving the pattern for which files we want to read. So in this case, we now open our curly braces. So we're going to say what this function is going to do when we call it. So we want to get our file names. And we use our list.files built-in function. And it requires a path, a pattern, and we want the full names. So path is what we are given as input, so our folder argument. And then next comes pattern. And the pattern is our pattern that the user or the person who's calling the function is going to give. And then we have to say we want the full names. So we have to set that to true because the default is false. And then after that, since we have our file names, we can go for, and then we can remember it's in a for loop, you have a variable in collections. So our collection is our list of file names. So file names, and then we can call this variable whatever we would like. So I'm just going to say F. So F means file, then file names, and I'm going to use our analyze function. F. Okay. So there we go. We have a second function, analyze all, which will essentially do what we were doing outside of a function over here. But now we can give it any folder name and any pattern now. So it's a bit more general. So if we didn't have a data folder and we actually wanted to look at a different set of CSV files, we can now just use this analyze all function. Okay. So when we run something like analyze all, so we need to call it. So analyze all, and we told we need a folder. We know the default is data, and then we want a pattern. So let's see if there's already a default. We can just do that. And our pattern is inflammation because that's what our CSV files start with, and a dash. And then we need to do the regular expression part. So we want to say we allow any digit from 0 to 9. But as we see here, we have 2 digits always. So that's why we put that in the curly brackets to say I want 2 digits which can range from 0 to 9. And then we end with the .csv. So it'll find files that have this name in it. Let's see if that worked. No. Invalid path argument. If I just give this, pattern is missing with no default. Okay, so if we just then do data, and then, okay, wait, this disappeared. Okay, let's try that again. Okay, so that worked. And the problem that I have here is, if we look over here, it thinks that we're working with a variable because I didn't put quotation marks. So I actually need to say, I want you to find the string data, not a variable called data. So let's see now what happens. I'm not sure what would have happened if I did this. I think I might still have issues. Yeah. Pattern is missing. So it is thinking that I am giving inflammation.csv as my folder name, which we don't have. But if we just have our comma in front, now it works. So the invalid path argument here was because we had not put data in quotations. So it was trying to find a data variable which didn't exist, so it didn't know what path to use. Okay, so we've got this analyze all function, which I think is working. And then, so it makes 3 plots per CSV file. So that's 36 plots. But if we would then want to take these plots and send them to someone else, we would have to try and save them individually, which is not, if we go here to plots, we'd have to see if we could export as save as image, and that would take a very long time to do manually. So instead of doing that, we want to try and save our files. Okay. So we're going to learn how to do that. Now. Okay. But before we can do that, we're just going to go through something called conditionals. Because we want to try and save these files, but if there's maybe you want to save some files, but not other files. So you don't want to say either save all 36 files or none at all. So we're going to learn how to be selective about how we're going to save things. And in order to know how to do that, we're going to use something called conditionals. So let's look at some conditionals. Let's say we have a number. Let's say it's 37. I can use greater than and less than signs to get a Boolean value back to see whether something is true or not based. So like, for example, is number greater than 100? So just like normal mathematics. So we have a number, its value is 37, and then we ask, is number greater than 100? And it says false because 37 is not greater than 100. And then we can check the other way. Is number less than 100? Yes, because 37 is less than 100. So we can use the greater than and less than signs to get a Boolean value back of is this true or is this false? And we can use this with what we call conditional statements. You might also know them as if-else statements if you have used other programming languages before. So we're going to have something where we have our number again. We know it has the value 37. And then we're going to use this statement. So it looks a little bit like the for loop. So when we had our for loop, it would start with the keyword for so that R would know that we're working with a for loop. So with this if-else statement, it uses the keyword if. So we start with the keyword if. Then we have our condition. So our condition is something like, is it greater than something? Is it less than something? Is it equal to something? It's the condition by which you're going to decide whether you want to do something one way or do something another way. So we're saying if our number is greater than 100, we are going to do whatever is inside these curly braces, inside this block. So if our number is greater than 100, I'm going to print greater than 100. Then we get to the next part. So we have our if section is done. So if we know that this is greater than 100, then we're going to print greater than 100. Then we have our next part, which is the else. So if it's one way, we do this. Otherwise, if it doesn't meet that condition, we're going to do something else. So else doesn't have these round brackets with our condition because we're saying with this if it's like this, do that. And then the else is saying in every other condition. If we did not find this, then the automatic thing is now to do this remaining bit. So you don't want to have else num is less than 100. It already knows that if it didn't meet this requirement, you're doing the else block. So in all other cases, we're going to print not greater than 100. Right. So we have if our variable num is greater than 100, we're going to print greater than 100. If this condition wasn't met, then we're going to do the else block, which is print not greater than 100. So let's see what happens. What are we going to expect it to print? Greater than 100 or not greater than 100? If our num is 37. You can put it in the chat. So we've got a number 37. We have our if statement. We say, if our number is greater than 100, print greater than 100. If we do not meet the condition that num is greater than 100, then we print not greater than 100. I see we've got one person saying not greater than 100. Not greater than 100. Second person. Okay. Let's have a look. Yes, not greater than 100. So what happens here is in the conditional part here, remember when we printed this, we got a Boolean called false. So it will, R will interpret this and go, is 37 greater than 100? It will say false. And then it will say if, and then false. It won't run whatever the code is in this block if this equated to false. And then because this part wasn't run, it then goes into the else and runs the else block. But let's try something else. Let's say that our number was 137. What's going to happen now is we get greater than 100 because it checks is num greater than 100. 137 is greater than 100, so it says true. So if true, and because it's true, it goes into this block here, and it does the print of greater than 100. And because this block was true, it doesn't go into the else because it's already run this bit of code here. So it doesn't, it's either one way, if it's like this, do this only. The else is if you haven't done the other part. So once it's printed greater than 100, it skips over the else. It doesn't print not greater than 100 as well. So yeah, it's like one or the other. It can't do both if you use an if and then an else. But we don't have to have the else statement necessarily. Sometimes you can just have the if portion. So maybe you just want to print when a number is greater than 100 and you don't want to print when it's not greater than 100. That's fine. You can do that. So if, let's say num is 37 again, we can just write the if portion. So if, and then our condition, because we have to say, well, what are we looking for? What's our condition we're looking at? And our condition is, if it's greater than 100, what are we going to do? We're going to print that it's greater than 100. Now, you don't have to have this else, because what happens is if this is false, then absolutely nothing happens, as we'll see here. So if I run this, just if, you see, we get no output. But if we have greater, so 137, if we run it again, we get greater than 100. So you don't have to always have an else after your if, but it's always required if we're going to use an if-else statement that the if part is there, because you have to always give it the condition that you want it to check against. If you try and do else, it's not going to know what you're talking about because you can't give else the condition. Right. Are if-else statements making sense? Basically, where you have a condition at the start with if. So if it meets the condition, it's going to go into this part and do whatever you say inside here. It doesn't have to be print, but our examples are doing printing. And you can then have this optional part afterwards, which says else. And that means if you didn't meet this condition, then we're going to do this next bit in the second code block. Is that making sense to people? You can put a thumbs up if you're okay with this concept. If we're going to keep using these conditional statements. Yes, Komatsu? Yeah. Not hearing you. Wait. Are you speaking, Komatsu? Sorry, I can't. I think something might be wrong.
Can you hear me now?
Thank you. Yeah.
Okay. I was saying that in Bash, usually when you open with an if statement, we then
Yes.
close with an fi, right?
Oh, yes. This part, because we have these curly braces, R knows
Yes.
where to close with this close of the curly brace.
Okay.
Yes. So
All right.
whatever's inside these curly braces is what's going to happen within this if statement. So you can put as many lines of code
Right.
here, and that all gets done within the if statement. And then once the curly brace is closed, that's it. That's
Close.
where if stops. Yeah.
Right.
Great. Yes. That's the same for all of the things that we've been working with, like our functions, because it now knows inside these curly braces what you must run when you do a function, and it knows that the function ends at the end of the curly brace. So, yeah, R uses curly braces to know what you're putting inside things like functions or ifs, if blocks. Yeah, great. Very good question. Um, okay, any other questions? I'm not seeing anything, but you're welcome to put up your hand at any point or, yeah, put something in the chat. Okay, so we've looked at if, and if else. There's one last thing that we can use. So sometimes choices aren't binary, right? It's not always, it's either this or that. Sometimes it can be one thing, a second option, and a third option, or it could be like four different options, or even like 10 different options. So there's something that we can use, which is else if in between. So let's try and um, do something like, hmm, we'll give the signs of numbers. Okay, so is a number positive? Is it zero or is it negative? So uh, find the sign of a number. So we're going to have a sign function. So we're putting our conditional inside a function. So our function is going to be sign. So this function is going to tell us if we give it a number, whether the number is a positive number, a zero, or a negative number. So we have to use our keyword function, and we're going to be given a number, which we have to find the sign of. So our argument is num. Now we want to see, is it positive? So what conditional would we use to know if a number is positive? You can give it a guess. So our conditional could be yes, so greater than zero. So how would we write that in R? So we're looking for when num is greater than zero. So what would I put inside these round brackets? Okay, so our argument num, which is going to hold our number that we given by the function, if it's greater than zero, we're going to return 1. So we're going to say this is positive. So you could probably type, if you wanted to, something like positive, but I'm just going to return actual numerical values. So 1 if it's positive, 0 if it's 0, and -1 if it's negative. Okay, so we've got our if statement, and now we want our middle condition. And we do this now using a new keyword, else if. So we have, if it's like this, we do this, else if it is like a new condition. So else if, so now we want to see, is this number equal to 0? So if you want to know if a number is equal to 0, we use double equal signs. So this is saying if our number is exactly equal to 0. And then we have open our curly braces. So we're working, this is what's going to be executed now if we go into this else if block. You're going to return 0. And then we can end with our else statement. And because it's the last one, it's whatever happens, whatever was not found in if or else if, everything else goes into else. So we don't have a condition. So we don't have the round brackets with any conditional. And then what are we going to run if it's else? We're going to say, well, if it wasn't positive and it wasn't 0, then the only thing it can be is negative. Okay. So even though this part, else if, starts with an else, because we have this if part, we're saying if we now have this condition, we want to do something. So it doesn't, you must still add your condition here in your else if statements. Don't leave it out like you would in else, because you still have to say, this is now my second condition that I'm looking for. So the first one was an if, then our next one was an else if, and then you could have as many additional else ifs if you wanted. And then at the end, you would end with an else, and then that's what happens when it didn't fall into any of the other categories we're looking for. So let's see. We've now created a sign function, right? We defined it, and now we want to see, well, what happens if we run it? So let's try a couple different things. So let's say we have the number 10. We're expecting it to be positive, so what do you think this is going to return? Based on, okay, we've got one person saying 1, another person saying 1, another 1. Okay, let's check. Yeah, so it met the first condition. If it was greater than 0, it returns 1, and then that's it. It doesn't need to look at any of the other else ifs or else because it was true immediately in our first block. Okay, let's try another one. So sign, and let's say -3 now. What do you think it will return if we run this, execute this line of code? -1. Okay, let's see. There we go, -1. So what's happened is it's gone, okay, I've provided -3 as my number. If -3 is greater than 0, well, is -3 greater than 0? No, false. So because this is false, we can't go into, oopsie, we can't go into this block of code, so we can't return 1. Then we look at the next condition, else. Okay, so if our number is equal to 0, well, is -3 equal to 0? No, so we can't go into this block. And so the only thing we're left with is else. And so what it does is it returns -1. And then if we did the last type that we can test, sign of 0, we get 0 because it doesn't, 0 is not greater than 0. But when we go into our next part, else if, is 0 equivalent to 0? Yes, so it returns 0 and it doesn't go and then into the else part at the end there. Okay. Okay, we've been working with integers, whole numbers. So let's now see what happens if we don't give it a whole number. Let's say we give it 2/3. What do you think it's going to give? Remember, when we do 2/3 here, it's probably going to convert to a decimal like 0.66666666 recurring. What do you think it will give as a sign? Do you think it'll give 1, 0, -1, or nothing at all? I've got one person saying 1, 1, someone saying nothing, -1, 1. Okay, let's see. Let's run it. And it gives 1. So let's go through it one by one. So we get given a number. So 2/3 is in decimal form 0.6 recurring. So is 0.6 recurring or 2/3 greater than 0? So if we have 2/3 of something, it's more than nothing. So this will equate to true. Let's check. So let's check, is 2/3 greater than 0? Yes. R considers that true. 2/3 is bigger than 0. So it returns 1. So this operator, greater than or less than or equals to, doesn't only work on whole numbers. It works on decimals, anything like that. Because we can know mathematically that 2/3 is bigger than 0. Okay. Does that make sense? Is everyone okay with if, and else statements? Getting one couple thumbs up. If not, you're welcome to raise your hand or put something in the chat. Okay, I'm seeing lots of thumbs up, so I will continue for now. Okay. There's a couple other equality signs. So as we know, we've just looked at greater than, less than, or equal to. We've got a couple other operators. So something that we can have, so let's say our num is 3. The next things that we can look at are greater than or equal to. So if num is greater than or equal to 3, that gives true because it's greater than or equal. So we have the equal sign after the greater than sign. So that's greater or equal to. We can also do, is num less than or equal to 3? That's interesting. Huh? There we go. That was weird. I don't know why our number was being treated as false. Maybe I didn't run this part. Okay, so num is 3. Num greater than or equal to 3 is true. Num less than or equal to 3 is still true because the number is 3 here. And then the last, so this is greater than or equal. And then this is less than or equal. And then the last one is not equal. And that is a bit different where we have a exclamation and then an equal. So this is saying print true if it's not equal to whatever you've got over here. So we're going to get false, right? Because num is equal to 3. So it's false if we say that 3 is not equal to 3. So if I chose literally any other number here, like is 3 not equal to 4? That's true. Is 3 not equal to 0? That's true. Okay, so there's a couple other operators you can use, so it doesn't have to just be greater than, less than, or equal to. And remember that equal to always has 2 equal signs, not just one. Okay. So we've looked at things where we have like one condition, so something like, is it greater than something? Is it less than something? Is it not equal to something? But in some cases, we might want to have more than one condition tested at one time. So maybe it has to be that your number is greater than 10, but less than 20. So we're going to see how we can do conditions where we have to combine more than one together. So when we combine them, there's 2 ways of doing this. There's 2 different types. So there's two ampersands together, that means and. So it means you have to have condition one and condition two met before something else happens. Then we have the two vertical bars. So what you were using for piping in shell. So if you put two vertical bars together, that means or. So it could be one condition or this other condition. And if either of them are met, so both conditions need to be met here, and either condition must be met for this or. Okay, so it's very similar to in mathematics and like sets, things like both options have to be together. So it's like in those Venn diagrams where it's like the and in the middle where they must overlap for both. And then or is it could be anything in this with that is in this condition or in this condition must be met. Right, so let's try and write one to see how this works. So I'm going to have my if statement and I'm going to have my condition, but now we're going to combine conditions. So I'm going to say if 1 is greater than 0, so this has to be true, and our second condition has to be true, and our second condition needs to be, is we're going to say is, if -1 is greater than 0. So if this condition and this are true, then we're going to go into this code block and print both parts are true. And then we're going to have our else. And then we're going to say, well, if that wasn't, then we're going to say at least one part is not true. So if we run this, we get at least one part is not true. So when we go into our if statement, we see if 1 is greater than 0, is that true or false? So 1 is greater than 0, that is true. So we know that that's true. And then we have to check, because this is and, both things have to be true. So we have to check this next part. And it goes, okay, is -1 greater than true? Is -1 greater than 0? Sorry. That is false, right? Because 0 is greater than -1. So that's false. So if we get a true and a false, because both of them are not true, we then can't go into this if statement. So it will say, go into the else and print, at least one wasn't true. However, if we do the or statement, so 1 is greater than 0. So now instead of and, so instead of checking if both are true, we just want to say if one of these, if this condition or this condition are true, then we're going to print at least one part is true, else, and then print neither part is true. So if we run this, we get at least one part is true. So we had, is 1 greater than 0? True. Is this -1 greater than 0? False. But we had at least one true. So it was like, okay, I've at least one or the other was true. So I'm going inside the if statement and printing at least one part was true. The only time it would go into this else is if every statement chained with an or. So if this condition and that condition were both false. So this is like if you have one if you have one or one, it gives you one. If you have one or zero, it gives you one. Same if it was zero or one. And then the only time that it doesn't work is if it's zero or zero, it gives you zero. But I think most have you encountered these sorts of Boolean things before, like where the things are true or false based on ors and ands? I think this might be in some first year maths, um, some first year maths uh, lessons, but yeah. So or means if at least one thing is true, so one is true for us and zero is false. So as long as at least one thing is true, it'll always give true for or, but with and both things have to be true, otherwise it will always give false. Okay. Any questions with ands and ors? I'm not seeing anything. Okay. Right. There is one difference that we have. There's a special case, and that is we've been working with numbers. But what happens if we didn't get rid of our missing values? What happens with our conditionals when we have missing values? So let's say we have a missing value in our variable a, and then what happens if we say a equal to 1? Let's see. It gives us not true or false, but in a. Okay. And then even more interestingly, what do we do if we say, is a equal to a missing value? Instead of saying, true, I'm a missing value, it actually says NA. So you need to, the way that R works is that even if your value is a missing value, you still cannot use an equivalent to check whether what you've got in your variable is a missing value or not. Um, yeah. So you can't use this. So for example, if we tried doing that, so if a is equal to a missing value, then we would say let's print something like hello, and it gives us an error. It says for this line of code, it says we're missing the value where true or false is needed. So it's telling us that this is returning NA and not the Boolean true or false. So we have to use this is .NA function. So that would be, this is a built-in function. So instead of saying is A equivalent to a missing value, we just use the built-in is NA for A, and that gives us a true or false. So if we try again, if is dot in A, so if this is true, we're going to print hello. And there we go. Because it's a missing value, it says this is true. If true, so we go into the code block and we print hello. Yeah. So just a word of warning, if you use the is equivalent to NA, you're not going to get a Boolean back. You need to use the built-in function is.na. Right. Okay. I'm going to show you a new function that you can use. So before we'd been using something like plot, where we'd plot something like, I don't know, something like that. So if we just plot for each day what the value was for inflammation, you could do something like that. And that gives a scatter plot, I think. Is this called a scatter plot? But you can specify what type of plot you want. So let's say instead of that, I want a blocks plot. You can say box plot, and it knows what you are wanting to use, and I'm giving it a set of data. So let's say for each patient on day 4, what was their inflammation level? And there we go. We get a box plot. So that's quite handy. There's different types of functions that we can use to plot different types of plots. So now that we see this box plot, we have a box plot, and then there's another type that we're going to look at called strip chart. I must say before this, I'd never heard of one before. Let's see what that does. Let's see that. That looks a bit interesting. So there are many different types of plots that you can use. Now, for our challenge, we're going to try and do, we're going to write a function. So we want a function called plot dist. And in this function, we want it to plot a box plot if the length of the vector is greater than, greater, I'm just going to go on to the next line, greater than a specified threshold, and plot a strip chart otherwise. So plot the box plot if the length of the vector you give is greater than some threshold. Otherwise, you plot the strip chart. And you'll need these box plot and strip chart built-in functions to do that. And let's say your data is coming from our inflammation.01.csv file. And remember, our header must always be false because we don't have a header in the CSV file. And then we're going to be able to want to call some plot dist. And we're going to say our vector is all the patient data for the 10th day, because column, day 10, and our threshold is 10. Okay, so I'm going to give you guys 10 minutes to see um, whether you can create this function that uses that plots box plot if it's over the specified threshold, otherwise plotting a strip chart. And feel free to ask questions in the chat, talk with one another towards finding a solution. So it's 9:57. At 10:07, we will go through this question together. Someone said that they got disconnected for 2 minutes or so. If you've heard what we are doing in terms of um, the question, the challenge that we're trying, then you're all caught up. Um, there hasn't been any discussion on the chat or anything. Hi, is someone trying to say something? Sandile, uh, I'm not sure. Did you maybe paste? Yeah, the wrong screenshot. Yeah. Sandile, you're very close. The only bit is we need to check that the length of that vector is greater than the threshold. So our threshold, um, we're checking the length of the vector against the threshold rather than checking the what's kept in threshold against a number that you've got inside your function. But in a minute or so, we'll go through it. But yeah, it looks very good. No problem. Okay, it's been about 10 minutes. If anyone else would like to paste into the chat what they've written, if they would like, or ask any questions, um, you can do that now. Otherwise, I'm just gonna get going through this function. Okay, so we've been told we have to create a function called plotDist. So I can say, okay, I'm creating a function, well, a variable name, plotDist, and I'm assigning to that a function. And we need to plot a box plot if the length of a vector is greater than a specified threshold. So we're going to give it both a vector, so some set of data. So you could call this whatever, you could call it data. I'm going to call it X and our threshold. So we have some vector X that we're going to look at and some threshold that we're going to use. Okay. So we've defined our arguments for our function, and so now we're going to open our curly braces so that we can say, what is this function going to do? What's going to happen when we run this function? So they say, plot a box plot if, um, otherwise plot a strip chart. So with that if and otherwise, I know we're working with an if-else statement. So we're going to start with our if. So if, and then we need our open brackets. And now it's okay. Within these brackets, we have to put in our condition. So what is the condition that we were told? Plot the box plot if the length of the vector is greater than a specified threshold. So we need to find the length of a vector. Does anyone remember what built-in function we can use to find the length of any vector? We saw this one once or twice yesterday. So if you suddenly remember what it's called, you're welcome to paste it into the chat. Is it len? Let's see. Len of x. Okay, well, let's go with len and see. If len of x is, and now we're saying if it's greater than this threshold. So if len of x is greater than our threshold, so if that's true, we're going to do whatever's in this block here within these curly braces. And what do they want us to do? They want us to plot a box plot of the data. So we need to call our special box plot built-in function, and we need to plot X, our data that we've been given. Okay. Yes, I think it's length. But if you forget, you can always try running it with len and seeing what happens. It also depends on it can get very confusing if you code in multiple languages because these built-in functions have slightly different names. So if you're in Python, you might see a different function name and then you remember one and not the other. So it's really not a problem. You can always run code, see if it works. If it doesn't work, then you try something else. Okay, so we've done our if. So we're told otherwise. So if we don't meet this condition, in all other cases, we're plotting a strip chart. So we just need our else. We don't have any other condition. So it's just else. If we're not plotting a box plot, we are plotting a strip chart. So we can use our strip chart built-in function and do that with X. Okay. Right, so we've got a function now. plotDist. Now we can check whether it works. Let's try something like plot dist. And I want to try where we have for the 10th day all 60 patients. And then my threshold I'm going to say is 10. So if we've got more than 10 things in this vector, then it will print a box plot. Otherwise, we're going to print a strip chart. If we think about this, we have kept all 60 rows. So we should have 60 values. So we're expecting it to print out a box plot. Let's see if that works. And there we go. We see a box plot over there. And let's try the other way. So we want to see, are we getting a strip chart if we give it less than 10 things to plot? So instead of giving just the using all rows and one column, let's say we only want the first 5 patients. So the first 5 rows in column 10, and we keep our threshold the same. What happens? We should get only 5 values, so that's lower than our threshold, so it will print a strip chart. And there we go. We have a strip chart there, where some values seem to be 3, 4, 6, 7, and 9. Okay. If we had kept len here, let's see what would have happened. If we tried running this, it would just say error in NITheCS, could not find function len. So at that point you go, oh wait, actually, what is this function called? You could try and look it up online if you've forgotten. But often if you start typing in len, you'll see something like length come up, and then you can change it to what you want. And then it works. Okay. Now let's go back to our inflammation information. So we want to save some files, some plots, and not others. So when we want to save a plot, there's different formats you can save it as. So we have our analyze function. And for now, so remember, analyze is where we just use one file name. Analyze all is where we create plots for all of our data sets. So I'm just going to do it for one. And my input is analyze. Let me just check, is analyze in my global environment? Where my functions, analyze, yes. And it just requires a file name. So I'm just going to give it data and our first inflammation file, inflammation01.csv, right? And that plotted 3 plots for the average, min, max. And the way that we can save all of them is using to a PDF format, is calling something called PDF above. So PDF, and then if we see it's a built-in function, and the first thing is file. So we need to give it a file name that we want to save this as. So I'm going to say inflammation01.pdf because we're making a PDF. And dev.off comes after that. And dev.off means it doesn't redirect the plots to show them here in this pane over here, I believe. So let's see what happens if we run this. Okay. Let's see what happened when we ran that code. We go to our files and we've got one inflammation.pdf. Okay. I'm going to open it in my document viewer, but you're not going to see it. Okay. And the PDF, if you click on your PDFs, you can see there are 3 pages. And on each page, there is one of our plots, scatter plots. So we say in the first line, okay, I want to save our outputs to a PDF file that's called inflammation01.pdf. Then we run our function analyze, which creates our plots. And then we have dev.off to stop it redirecting those plots. So if we did keep running PDF and this each time, and we didn't include dev.off, you're going to keep saving to the most recently opened file that you have. So you aren't closing your PDF file by doing this. So this is good. So yeah, just try and remember to include dev.off because this keeps the connection open to whatever file you've run PDF for. So it's like going to be using up a lot of memory trying to keep the connection going, and it could get problematic. So, and if you've forgotten to use dev.off, they'll have to keep running dev.off until everything is then closed. So try and get in the habit that if you're going to write something like PDF, you automatically at the end put dev.off at the bottom of your code and run that as well so that we can see that we close. Okay. So we see how we can save one file, but we want to have a function where we go through each of our inflammation CSV files and we decide whether we're going to save or not save to those PDFs. So we can change our analyze function. So we're now going to have our function. And remember before when we used analyze, we just had our file name. So we still want to do that. We still want to say, I want you to open this file, but we're going to have a second argument now, and that is going to be called output. And output is going to be the name of the file that we're going to want to save our plot to. So something like inflammation01.pdf. Okay, and for output, I'm going to give it a default value, which is called null, which means nothing. So our output default is going to be nothing. So null is different to missing values. Null is not the same as NA. Okay, so analyze, we need to do exactly the same thing as what we did before. So I'm going to go up to analyze. Where did we write analyze? Analyze all. Okay, here's my analyze. Analyze. So what it does is it plots the average min and max inflammation over time. Okay. And then this is what we had in our original analyze, where it would just plot and we didn't do anything else. So now we're going to have, because we have two inputs, so we have file name. So that's the character string of a CSV file. And then we have a second one now, which is output, which is the character string of the PDF file for saving. So when we call this function, we're now going to say, what file must I read from? And what is the name of the file that we're going to save our PDF to? Okay. So we have our reading in from our file name. We read in from the file with our particular file name. We say header is false. Then we calculate the average day inflammation with the apply function using mean, and we plot it. And then we do the same for minimum and plot and maximum and plot as before. But now we want to do something where we want to say if our output, so if what we have here in our argument of output, if it's not null, so if we have some sort of string, we're going to want to print this out to the PDF that's there. Otherwise, we're not going to want to do anything. So we're just going to want to do what we've always done, which is do the plotting in here in our file area. So in our plots, we'll just see it come up there and we won't save. So there's we're going to have our if statement because if, and now we want to say if our output is not null. So like NA, we couldn't use the if it's not equal to like that. It will give us a problem. It won't give us a Boolean. So instead of is NA, we're going to use is null. So this built-in function is null, checks whether what's stored in our variable output, if it's null or not. So at the moment, this is saying if our output is null, we will do something in this part. But we don't want to do something if it's null. We want to do something if it's not null. And so what we do in that case is we put an exclamation next to the function is null. So what happens here is it will, R will work out what this is. So currently output would be null if we didn't give it anything. So it will go, is output null? It'll see that it is null and return true. And then there's this exclamation over here. And what that exclamation operator does is swap the Boolean. So if you had true here, with this exclamation, it turns it into false. So it's like the opposite. It's not what it was. And if this was false, with the exclamation in front, it becomes true. So that's what this exclamation at the front is doing. It's making it the opposite of what the output was here. So we're saying if output is not null, then we're going to do something. And what are we going to do? We're going to say, oh, we want to save a PDF. And we want the PDF to have the name that the person sent through, who called the function. And then the other bit that we must never forget, if we call PDF What do we always have to have? What always has to happen at the bottom? Can anyone put in the chat? So if I call PDF, yes, we have to have dev.auth. But do we need to do dev.auth if we're not printing? So if our output was null, do we need it? No, we don't need it. So we need to have another if statement. So if the isNull function, when it checks what's in output, if it's not null, just as before, then we're going to do dev.auth. Okay. And the reason why we haven't done PDF and then dev.auth right underneath is because you have to plot the things first, and then you can close the connection. So if you try and open the connection and then close the connection and then try and plot everything, it's not going to work properly. So that's why you have to have two if statements. First check, do I want to plot? Have I been given a string that I can use to plot? Then, okay, we'll open up this PDF so we can save to a PDF with that name, but only if we've got a name for it. If it's null, we're not going to do that. Then we do everything as normal, where we read in the data, we calculate the average, min, max, and plot. If we've opened up this PDF file, it's going to be saved to the PDF. If we haven't opened it, then it's just going to plot to the console part normally. And then at the end, we check again, okay, well, if we did send it to a PDF, if it wasn't, if we're checking the same thing again, if it's not null, that our output was null, then we can close our connection. Okay. So is this new analyze function making sense to people? Please put up your hand or anything if you would like to ask a question. Yes, lots of.
Can we go through the mention from the top again slowly before we run it so that we just get a chance to think it
Yes.
through?
Okay. Do you want me to go through it again, or do you want me to just let you go over it in the next minute or two by yourself? Or
Oh, we can do it together.
okay, right. So we have our analyze function. Okay, it has two arguments. So we will give it the file name that we want it to read data from. So our CSV file that we have our information stored in. And then we now have a second argument, which is called output. Okay. And we have a default value attached to it because we have this equals null. So our default value is that if the person who's calling the function doesn't give a second argument, it's going to assume that the output is null. However, if the user does give a second argument, it will be a character string, which is going to be the name of the PDF file that we're going to save. So you could have something like the user giving inflammation01.pdf as our second argument. Okay. So we have a file name argument and an output argument. Now we want to say if we see nothing in our output, like if there's no string, so if we don't have a name to save this plot, these sets of plots to, then we don't want to do anything. We only want to plot if we have a name for our PDF file. And the way we check that is to make sure that what's in our variable output is not null. So we have a function built in R, which is called isNull. So we can use that function to check, is our variable, does it hold a value which is null or not? If it does, it's going to give true. If it doesn't hold a null value, then it's going to give false. And then just before that function part is null, we have an exclamation mark. And that is an operator, which is the same thing in maths as not. So it converts, if you had true, it makes it false. And if you had false, it makes it true. So it's the opposite. It does whatever, it changes whatever was executed and determined by R here as either true or false. It makes it the opposite. So false or true. So from this, we can then say, okay, if our output isn't null, we want to say this is the name of our output that we want to write our plots to as a PDF. We just have this if statement. So if our output was null, we just don't do what's inside here. So if we get into this if statement, the only thing that's different is that it runs this line and then carries on. If this is false, we don't do the opening of the file that we're going to save our plots to. But whether output was or wasn't null, we then run the next lines of code. So that will be reading in the data from our file with the file name that was given, then calculating the average days inflammation per day, and then minimum inflammation per day, maximum inflammation per day, and plotting all of them. If we'd opened this and said we want to save to PDF, the plots will be saved in that file. Otherwise, we're just going to see it as normal in the console anyway. And then right at the end, we have the same condition again. It's exactly the same as what we had over here, because it's only when we had opened up a file that we're saving to, we then check again, okay, if we had this output that wasn't null, so that means we're saving to a file, then we execute whatever in this code block, and that is dev.auth, which closes the connection to the file. So it doesn't keep the connection going if you go and run this code again and again to different file names. If you kept opening connections, it would be like, I've got like 12 files open for you at once, and it might bomb if you don't have enough memory. And it's just good practice to just try and close any connections. Once you've finished writing to the file, just make sure the connection is closed. Okay. Does that sort of go through what we're doing? Okay. Some thumbs up. Okay. Right. Any more questions? You're welcome to ask. Could you please copy and paste your code into the chat? What, the analyze function, or because I've got quite a lot, I've got like over 500 lines of code, so I can copy the analyze one in. Okay. Here is our, okay, it hasn't got the indentation correct. You're going to have to make sure that the indentation is okay. So it's all Yeah, it's a little weird with the formatting. So just make sure when you open curly braces, just make sure it tabs so that it knows that you're not working right here underneath. Okay. Then let's keep going. Okay, so we've now changed our code. Sorry, I've just got something in the way for me. Oh dear. Okay. Um, Sorry about that. Zoom is just being difficult. Okay, there we go. Now we have created our new analyze function, so we can say whether we want to save to a PDF or not. And now we can try and use it. So let's call it, go analyze, data, inflammation 01.csv. And I see I'm actually going to do like 3 here so that we might get a different output. Yeah. Okay, so because we only gave it one argument, we just gave it the name to load the data from. And so it uses the default of output being null. So we don't save anything to a PDF. But we can also save it. So we can do output is inflammation 03.pdf. Let's see, does that work? Yes. And now if we go to our files, we now have an inflammation 03.pdf that we can click on and have a look. And there we go. We've got 3 pages, all with the different plots in them for that one. Okay. How are people feeling? Do you want to have your 30-minute break now? There's a little bit extra with this where we learn how to create folders so we can save our outputs in folders, not just right here where you're working. I don't know if you want to go through that quickly and then have your break, or whether it's time to have a break now. You can break, please. Okay. Okay. Then, okay, what's the time now? It's 10:40. Let's have our break until 10 past 11. You're welcome to ask us questions in the break in the meantime, or put things in the chat.
Emily,
Yes.
so when we run our analyze function without
Yes.
the output, right? And it uses the
Yes.
default now.
Yes. Now.
Isn't it that we then expect to see the plots on our console, even though it's not saved to the PDF file? Isn't that the
Yes.
expectation?
Yes. So we're still going to see it plotting it over here.
But for some reason, unless if I'm missing something, I don't see any results. No plots when I run it
Ah,
without the output that is.
um, okay, so what? Absolutely no plots come up at all. So you have no
Yes.
plots to go through.
Yes.
Okay, let me just
Oh,
check myself again. I just want to check whether. So I'm just going to change the CSV file because the average day inflammation plot changes a lot. So I can see whether it has changed when I run mine.
it
So
does.
it does. Yeah, we can see this looks a bit different here. So when I run my analyze with a different CSV file, I get a different plot that's still being printed over there. Unless your permissions are different, but you'd have to go into your settings and change that, I think. Um, okay, so maybe then the best thing to do is just take out two lines. Maybe let's do um, the average. So we already have that in our global environment. So just try and do average
Yes.
day, yeah, and just run those two and check, is it printing, is it changing the plot? Does a
Okay.
plot appear? So copy it out of your function,
Yes.
run those two lines. Okay, so it suddenly made a plot.
Well, I think it's probably something to do with my plots console
Yeah, the
again.
only thing I can say is rerun analyze. Make sure you've got your new version fully in your, because we had an old one called analyze as well. And then, so just make sure that you've run this and got the updated version of analyze, and then try running it and see whether max suddenly appears or not. The only other thing I can think of is if your console is too small or something, and so it won't plot. But then it usually gives an error at the bottom when you run the code saying that there's a thing where it's the sizing is wrong or something.
Well, I'm just gonna something else and get a plot before.
Okay, so have you got one plot
But but
here?
but when I run it with the output, I can see the PDF file being produced. So
Okay,
it's just
okay, so
that
you
I
can,
don't see the
okay,
plots.
plots.
Mm.
That's interesting. I wonder why. Um, yeah. Okay, you might have not used dev.auth once, and that's why it's also going wrong. So
Within
it's
within my code.
so just here, just do dev.auth and run. Do this until the console displays null device. Then try again.
Okay. Well, it keeps on saying could not find the function.
What? Dev.auth.
Yes.
So what's your error? Cannot shut off down device. Cannot shut down device one is what I get, the null device. And then at that point you
Okay,
can rerun
mine says that could not find function def.off.
dev dot off and then you have brackets.
Yes.
Oh, okay. Can you paste in the chat so I can see exactly what it's showing?
Oh, I get it. I said def, not dev. Okay.
Yes, it's dev. Yeah.
Yes. Okay. So now it says null device.
Okay, now rerun your analyze and see what happens.
Okay.
Okay,
It
is it
works.
popping
Thank you.
up? Okay, great.
Yes.
Right, it is 10 past 11, so our 30-minute break is up. Right, so I think it's important to just restate for everyone. Um, if you're suddenly not seeing any plots come up when you run analyze in this plots place over here, it may be because the files might still be open. So make sure that when you run dev.auth, you get a null device one part here. Um, Once you've reached null device, you can then try and rerun your function and it should all work normally and the plots should appear again. So it might just have been that you'd opened up one PDF and hadn't closed it, and then you then paired them after that with dev.auth with your PDF being opened, but that one opening without using dev.auth could have caused a little bit of trouble. So just make sure when you have dev.auth, you see null device. Okay, right. So we have got our analyze function where we can either save or not save these plots for one file, right? We have to give it just one file name. So we might want to do this for all of our inflammation CSV file data, but in order to do that, before we get to that, we want to try and save our results in a separate directory because if you have thousands of files and you run this code, what's going to happen is you're going to get information O1, O2, O3.pdf, and it's going to fill your main directory very quickly with all sorts of files. So just like we had our data folder here, which had all of our files inside. That's like, it's nice. It keeps all of your input files in one place. We're going to make a folder that will keep all of our output files in one place. And we're going to call it, so we're going to create a folder results to store our output PDFs. So you can go to the shell and create inside this folder a you can create your results folder inside our novice inflammation if you want with make directory mkdir and then results. But I'm going to show you how you can also do the same thing without having to use the shell within RStudio. And that is a built-in function, and it's called dir.create. So for directory.create. And we're going to say, please create a results folder straight inside where our current working directory is, which is in our novice inflammation. So if we run this, let's see what happens. Let's see. Yeah, right at the bottom, we now have this empty results folder that we've just created. So now we want to save all of our PDFs into this results folder. And so we can do that by doing analyze. So we're doing this for just one for now. So we need our file name that we're loading our data from. So that's in our data folder, data inflammation 01.csv. And our output is where we're sending it to. So we've made this new results folder. So we're going to put it in results. And then we have our / to say, put it inside this folder. And what's our name? Inflammation 01.pdf. So let's run this. Okay, we go in and have a look at results. And there we go. We've now got our inflammation01.pdf inside our results folder that we created. So you don't have to use directory.create, so dir.create. You can use the shell if you prefer that, or your file explorer, but if you want to code it inside your R script, this is how you do it. Okay, and remember, when you want to put your output in that folder, you have to give the name of the folder and its path. So for us, results is right here in our path, so that's why we start with results. Just like how we started with data, because it's the folder right inside our novice inflammation. We don't have to go searching through other folders to find where these are. They're right there. Is it just on my end, or does anyone else not see anything going on Emily's console? Oh, it's back. Okay, good. So can you see I'm on line 552? And I've got my console at the bottom down here. Yeah, great. So we have our analyze. So we can say, here's my input that I want you to load the data from, and this is the file I want you to save it to. So now let's try and do that, but we want to do this for all of our different files. But in order to be able to do that, we need to work out how we're going to do the save based on what our input is, our output. So for example, if we had inflammation01.csv, we want to save it as inflammation01.pdf. And same for like inflammation03.csv, we want to save it as inflammation03.pdf. So somehow we're going to have to substitute this .csv ending with the .pdf ending. And then we need to save the plot to results. So let's first change these extensions from CSV to PDF. There is a built-in function. So let's say our file name. So F is for file name. Let's start with inflammation01.csv. We want to substitute this ending part to become PDF. And there's a built-in function for that, which is called sub for substitute. And you see here, it says you'd have to have a pattern, a replacement, and X. So pattern is what is in your original string. Replacement is what you want to replace your pattern with. So it's like a replace function in some of your text editors where you go control find, you then type in your bit of your string that you want to find, and then you can do a replace all or a replace using your text editor for some of these things. So it's basically like doing that. So what we're doing is we're giving it here the pattern that we're looking to find. So CSV. Then replacement, oh wait, remember, I forgot. You have to have it in inverted commas, otherwise it's going to start looking for a variable called CSV. So we want to say, I want you to find within the string CSV and change that to PDF. So wherever it says CSV, it's going to replace it with PDF. And lastly, X is the string that we wanted to search against. So for us, that's inflammation01.csv or F. So it says, okay, I'm just going to save here and I'm just going to stop sharing quickly and then share again. Hopefully that fixes it. Otherwise, unfortunately, I think you're going to have to just restart your Zoom on your end. Okay. I'm on line 556 and I've written our first substitute function, called substitute. Your whole script just disappeared. For your script or my script? I stopped sharing and then shared again. Oh dear, your whole script just disappeared. Did you control S to save? Because what you can do, did you close RStudio? Because what you can do is you can go to your novice information and you can click on your script.r and it should open it up again. Okay, so we just looked at the
I
sub.
sh
Yes, yes.
as your screen back.
Yeah, I'm sharing.
Okay, then I guess I'll have to restart my Zoom session because I
I'm
don't see
sorry.
anything on my end at all.
Yeah. Are other people seeing my
Okay,
screen?
I'll just quickly.
Yeah, other people are seeing the screen. Yeah, I'm sorry. I think something went a bit strange on yours. Maybe it was open a bit too long, the Zoom. It's almost like it's been overwritten. Not sure what happened. Um, okay. So you're in RStudio, but you can't see script.r anyway. Or is it just that there's nothing inside your script.r anymore? Um, okay, maybe if you can get a screenshot, maybe send it to Rehema or Takudzwa, and hopefully they'll be able to help you. Yeah, okay. They should be able to help you maybe undo or get back to where you were. Okay, right. I'm going to continue. Okay, so we're using substitute. So we're saying take, uh, look inside the string F, find where CSV is, and replace it with PDF. So let's see if that works. So we've got our string F, which is our file name, and then let's see if we can substitute it to F. We're exactly where we were. We're still at the file name and we're now substituting. So we're checking that. Yep, there we go. We see it's changed from CSV to PDF now. So the third argument is the string that you want to have something changed inside of. The first argument is the pattern that you want it to find. And then the second argument is what you want to replace the pattern with. Okay, so now we have a way we can convert our file names where it ends in CSV to PDF. And we can use a function called file.path to add a file name, a directory name in front of our file name. So let me give an example. So we have F, which is just our file, right? We don't have our results folder in front. There's no results dash. So what we can do now is we can go file.path. This is another built-in function. And we want to say our directory what we want to put in front of the name is results because we want to put it in results. But note that I haven't put a / there because this function is going to do it for us. Okay, so we say, I want it in the results directory, and then we'll have our file name that we have. So that is, we want the results, we want the PDF version to go in. So we're going to say, do our substitution where our pattern is that we're looking for is CSV. We want to replace CSV with PDF, and our file name that we want this to perform on is F. So if we run that line, we now see we have the results and then the / and then inflammation01.pdf. So this part we substitute so that CSV turns into PDF, and then file.path adds the results folder in front. So we have the results /. Okay, so we've got those bits working. So now we can update our analyze all function. So before, our analyze all was, we had a function, and let's go back up to where we had it before. Analyze all. We gave it both the folder that we were getting an input for and a pattern. This time, we're just going to give the pattern that we're looking for. And I'll show you why. So we're going to say our pattern is going to be given by the user, and that's it. And then here, for now, we're just going to we say that our data directory that we're getting our input from is called data, and our results directory that we are getting our results from is called results. So here is directory name containing the input data. And this is the directory name for our results. So PDFs. And now we want to run the function analyze for each file in the current working directory that matches the given pattern. So we want to load in our data. So, well, sorry, not load in our data. We want to create the list of file names that we want to analyze. So our list of file names, so file names, and then list.files, because we want to get a list of all the files that are in our path. And our path is, we've said it's in the directory, the data folder, so it's in data directory. And what do we want to look for? So our pattern is the pattern we tell it to look for. So we're saying, okay, look inside data, find all the files that match the pattern that I have been told is the pattern we need to match, and that creates a list of files that get put into file names. Now we can do our for loop, so we can go through each file in the file name. So we get a string with a file name, which I'm going to call F. So for F in file names, so we're going to go one by one through each file name that's in this vector, file names. And then we open up the curly braces. So this, what's inside our for loop, we're going to do whatever these operations are to each thing in file name. So F. So we want to get our output file that we want to, so we're going to get the output file name that we want the output to be sent to. So we want our PDF name. So I'm going to say file.path because here, this basically. So our file.path, and we're going to say instead of results, it's going to be our results dir here. So results directory. So we're going to add the results directory in front of our string. And what's our string? Well, we are substituting where CSV was. We want to put PDF for our file name F here. So we've got a file name like inflammation01.csv, and we want to change CSV to PDF, and then add results, and then the /, which we use with file path. And now we have the name of our output. And we need that output PDF name because when we call analyze, we have the file name and the output name that we have to give it. So our file name that we wanted to know is we want our inflammation.csv, but remember, as we didn't say we haven't got the full path here, so we're just getting inflammation01.csv. We don't have data / inflammation01.csv. So what I'm going to do here is use file path again. And I want to say put my data directory in front of my file name. So it's now for something like inflammation01.csv, going to convert that string to data / inflammation01.csv so I can find where this file is. And then our output is our PDF name that we've just told it to find. Okay, so what we've done here is the user is going to give us a pattern that we're looking for. We're saying our data directory is called data. We have a results directory, which we know we've called results. We're going to say, please look inside our input data directory and find all files within this directory that match the pattern here, which is what we will define when we call the function. And give me a list of these file names, and it puts it in file names. Because we didn't include another portion saying that we wanted the full path to be included, it's not going to give us the full path. So it's literally just going to give us the file names like inflammation01.csv without the data /. Okay. Then we go through our file names and we say, okay, to get the PDF, the output file name that we want, well, first of all, we need to change the .csv to .pdf. So replace CSV with PDF for our file name. And then add with file.path, we are adding the name, the string that's in results directory. So results as the directory name in front. So it'll create results dash and then whatever the name is, .pdf. Then we call our analyze function, which we have remade and we know now takes in 2 inputs. So you have to give it where it must load the data from. And if you just gave it F, it would give you an error because it'd say, I cannot find inflammation01.csv because you haven't told it which directory you have to look in. So that's why we use file.path and say, look in the data directory. So data directory data. And then for our output, Well, what do I want the output to be saved as? Well, the PDF name that we created just above here. Okay, so let's see. Does this work? Analyze all. And then I want to say find all inflammation dot. Huh? I don't. I think I'm going to do information star.csv. Let's see if that works. Okay, well, it ran something. Let's see what happened. Do we have anything in results? Nope, just our single one. So something went wrong there. Let's try put the star after the dot. No, or did it? There we go. Okay. So this is a regular expression and it says find everything that starts with inflammation and ends with CSV. So it's not even saying it has to be 2 digits in between or anything like that. And note that the star comes after the dot, not before the dot. So that's why nothing happened for me when I put the star before the dot, because my regular expression was wrong, so it wasn't finding anything. Okay. And this is the beauty of using functions. So at the moment, we are plotting the average, minimum, and maximum using analyze. But if you wanted to change what you were plotting, you could just go into analyze, change what you wanted. Maybe you want box plots instead. So instead of plot here, it's box plot. And then you can just run analyze all again and you've got all your changes made already. You don't have to. That's why it's nice to put functionality, like little bits of code that you want to use in these boxes that you can call using other functions. So you can quickly make any small changes you want and then reuse them if you can. Okay. So let's look at. Okay, let me ask. Is everyone happy with how we went and saved all our plots using PDF with our analyze all function? Are there any questions? Just put a thumbs up if you're ready to continue on to the next topic, because now's a good time
Well,
for,
I am
yeah.
having internet problems.
Oh dear.
I am
Uh,
having internet problems, so I'm a bit lagging behind.
okay. Can you please paste the code? Okay. Do you want the code because you're not able to type it up? I'm just getting worried because everyone should be able to be typing the code as I'm typing it as well. So, um, if you want, I can go through the analyze all function again, so that you have time to re-type it in. Um, if if you're not able to type all the bits and get it working, then I'm going a bit fast, probably. So, I mean, I can copy this in, but I'm not sure then
Please
how
do
much.
go back
Okay, you
through the.
tape you yeah, okay, you typed it, but you're getting an error. Okay. So errors often happen when we type something that isn't exactly like if one string is slightly different. Uh, Error in PDF output, cannot open file. Okay. So this is telling you errors are very useful because they can tell you what might be happening. So for one, we have error in PDF output, cannot open file, and then it says results. So it's saying I'm looking inside the results folder, and then I'm looking inside a data folder, and then I'm going to put in inflammation01.pdf. So what has happened is that we've got the data folder there as well, when what we're wanting to have is just results dash inflammation01.pdf. So the first thing to check is to make sure that you are in these lines of code. So what happens is we're saying at this point, find all the file names that are in the data folder with the pattern that we're going to give you. And it's going to list these files. Then we go into the for loop. And now here, I think is maybe where the problem may have come in. So the PDF name, you need to make sure that your path is results dir with the substitution where we're changing the CSV to PDF. Also make sure when you're listing your files that you haven't given it the true flag for the full name. So you don't want to have data slash inflammation01.csv coming in. You just want inflammation-01.csv. So let me show you here. If we have list files with coming from data, and I want my pattern to be inflammation.star.csv, we can see it's printing out inflammation01.csv with no data there. If we have, I think, is it full names set to true, then you're going to have this data in front. So we want to make sure that doesn't happen because it's going to try and look inside results and then inside a data folder. And it's like that data folder doesn't exist inside your results folder. So it's going to give a problem. So first, make sure that your full.names is not true. And then when you call analyze, you need to make sure that your output, you're just giving yourself giving output the PDF name. You don't want to do file.path, data directory, or whatever. So let's see. Update, analyze, or function, directory, their data, results data, path, pattern. Okay, yeah, I'm looking at it now. Run the function, analyze for each file, directory, given pattern, list files, path is data dir, pattern is pattern. For file in file names, PDF is file.path, results directory, sub, CSV, PDF, analyze where file path, data directory F, output is PDF name. Okay. And are you sure that you have got the latest analyze function? And so rerun analyze and analyze all, and then try and run analyze all again. And then let's see if you get the same error again. Rahima, if you can also put your error in the chat so we can see. I'm trying to see. This is what you might be spending a lot of time doing when you are coding. You will often get an error and you have to try and work out where it is that it might be going wrong, and it's not always immediately obvious. So sometimes, oh, fixed it. Had my syntax error and incorrect use of brackets. Okay, great. Um, Anthea, is it still not working? Unfortunately, still not working. So getting the same error again. Um, Also getting the same error as Anthea. Okay. I think it's because you wrote file name, not file names before the for loop. Yes, thank you. Thank you very much, Sandile. Okay, so when you look in the for loop, you say for f in file names. But when you did the list.files, you added it to a variable name called file name instead of file names. So we'd already set up a variable before called file names earlier up in our code. So it's referring back to that file names way up above and not the change you just did in file name just before. So you had file name here. So change that to file names and try run again. So in line file names is assigned list dot yay, great. Jason, maybe it's also something similar for yours. Okay, and then let's see, error in analyze file.path data drf output PDF unused argument. Um, are you sure you have rerun analyze, which has two um, inputs? Because we did have an analyze function before where it just wanted one argument. So I have the feeling that maybe what's happened is that you've still got that version in your memory. So when you try and give it those two arguments, it doesn't know. So make sure that you have run this analyze where you have the file name and output together, and then try again.
Can you share that again?
Okay, so with your error,
Yes.
it says you have an unused argument. Output
Yes.
is PDF name. So that makes me think that it's expecting only one argument and not two.
Okay.
And that makes me think that in your memory, it's you have the old analyze function where you only had one argument. So if you can find the analyze function where you had two arguments, both the file name and output, and run that one again, make sure that that is in memory, and then try and run analyze all again. It would hopefully work now.
Okay.
Yes. So, yes, great. Sandile as well. Thank you very much. Yes, a lot of these not a lot of these problems can come just from having a variable named a slightly different thing and then it referring to some variable that you had higher up above, and so it suddenly stops working the same way. So a good thing is to learn how to try and interpret the errors you're getting, and that comes with practice. You're going to see lots of errors. You can look them up online. You can try and decode what they're saying. Um, but yeah, if you're getting stuck, the internet is often quite useful to see um, what people suggest. Okay. Right. Any other questions before we move on? Do you want me to go through analyze all one more time, or is everyone ready to go on to working in the command line instead of with RStudio? Got one person who wants to get onto the command line, but just put up your hand if you want me to go through, or put in the chat if you want me to go through analyze all again. Okay, I'm going to go on to the command line. So I'm just going to stop sharing now because we're now going to get out of our studio and we're going to work with a text editor of our choice and the shell. So um, wherever you've got R running, that is where you need to use. So let's see if we can get this working for everyone here. This might be a bit tricky, but let's see. So I'm going to stop sharing. Okay, so let's close that. And what I'm going to do now is going to have a terminal. Okay. So share screen. Actually, okay. I'm going to share. Okay, can you see a terminal now? So we're going to be running R in this terminal. As I'm using Linux, I already have uh, shell on here, like bash. I can use bash. But okay, I think the best thing for us to do, I'm going to do I'm going to go into, I'm at home, right? So if I do print working directory, PWD, I'm at home. I'm going to go into my desktop. So CD, change directory to desktop, right? And I want to list what's in there. So I run ls. And there is my folder with my R stuff, R novice inflammation. So I'm just going to go into I'm going to cd R novice inflammation. Okay, so ls, this is where we've been working on in R Studio. What I'm going to do is I want to see how we can handle command line arguments. So in R, you will be able to not only run R only in RStudio, but you should also have R on the console. So you should be able to run something like R script and then something like uh, when we make it like readings.R and then give it some sort of flags and then be able to run that. But we haven't made our R script yet. So what we want to do is investigate some things before we get into that. So I'm going to use Nano because you should be able to see it, but you can use Vim, VS Code, um, gedit, anything you like. So I'm going to do Nano and create an R file called session info in, whoops, session info dot R, like that. And inside, all I'm going to give is session info. Okay. And I'm going to go Control X because it's Nano, save the buffer, yes. And I'm writing to session info.r, so I press enter. So if I look here now, when I list, I have a session info.r over here. And we can run our code with our script. Session info.r. So we're saying, please run our script, session info.r. Hopefully this works. Right. It now gives this long output. So it tells me what version of R I'm working with, what platform I'm using. It's saying that I use Ubuntu 22.04. And a whole lot of other things, like what sort of characters I'm using and the time. So I'm using South African time, etc. My time zone is Johannesburg. And yeah, so it gives me a whole lot of things like, okay, I've got in R my packages, these are already there. So if you can, create an R script called sessioninfo.r using anything. It doesn't have to be Nano. Put session, then capital I for info, and then your brackets. Save that, and then check that you'll be able to run R script session info.r. And something like this should come up. It's not going to be the same for everyone because I'm working on a Linux machine, so it'll look different depending on what distribution you are working on. And please put a tick next to your name if you have managed to get that working.
Um, what's what's
Yes.
what's written inside the script again? Session info. Can you
Session,
open your Nano
yeah,
editor once more?
I'm actually just going to use cat.
Okay,
Uh,
yes, please.
I've literally just got one line, session
All right.
info. So if you can get R printing out something like this, please put a tick as a reaction next to your name.
Emily, please go up a little bit on your shell.
Yeah, what would you like to see?
I just wanted to see the command R script session.
Oh, right. R script. So you say R script and then the name of your R script that you want to run. So we called it session-info.r.
Okay, thank you.
Okay. Okay. I see currently one person has got it working. I'm just gonna go. Okay. Um, I think this will be easiest if you tell us where you are getting stuck, whether that is running a certain command or whether you're getting errors when trying to run on your terminal. What's happening? Please go up on your script at the top. Which part? Which part? So, okay, I'm going to go from the beginning again. Okay, so I'm just going to go clear and I'm going to go CD. So when I open my terminal, this is what I start with. Okay, I have just this tilde sign here saying I'm in my home directory. Yes, Donald?
Meeting here. What is the issue? Meeting. Yeah, it's sort
S-
of like some training.
Uh, are you asking a question, Donald? I'm sorry, you're breaking up a bit.
I believe so. Yeah, yes, yes, in English. Oh, the recording is for that. Yeah. Yeah, that's what I was trying to do. Things it can happen. Yeah.
Donald,
Yeah. The last
are you are you asking?
thing.
I think you might be talking to someone else. Are you asking a question or
Don't know if they have like some GitHub page where they've uploaded that. I think I might have seen one earlier on. Don't
Donald, please can
remember.
you close your mic if you are not trying to talk to us?
I'm
Please mute if you are not asking a question. Thank you. Right. So I'm at my home. So I can see where am I with print working directory. So I'm at my home and I want to go into the folder that we've been working in with RStudio. So I know for myself, I put that inside my desktop folder. For others, it might be in a slightly different place. So I'm going to say, please change directory to my desktop. And so I can see, okay, I'm now in my desktop folder. And when I list, I can see all the things that are currently on my desktop. And I have my folder R novice inflammation there. So I want to get into that folder. So I go change directory, CD into R novice inflammation. Okay. And now I can use list ls again to check. And yes, we see our data folder, results. So this is definitely where I've been running my R. Right, now we're going to be running, instead of in RStudio, we're going to be running in the terminal using R script. So before we do that, we need to make our script that we want to run. And our script ends in .r. So we're going to create a new script. So for me, I used nano, and then I gave the name of the script I wanted to create, which was sessioninfo.r. But if you wanted, you could do something like gedit, or you could use VS Code. You don't have to use nano. So I run nano sessioninfo.r, and inside of here, I want it to tell me what my information is for my session when I run R script. So I use the built-in command session info and then open close brackets, and that's it. Okay, and then I saved that line in sessioninfo.r, and then to test that my R is working in the terminal, I ran R script. So that's the thing that you are using to run. So like, remember when we were doing Git, we had the name Git in front of everything, like Git add. So now we're saying, please, instead of Git doing this, running the script, we're now using R script. So R script sessioninfo.r. So I want R script to run sessioninfo.r. And I get this printout. Let me also just do cat sessioninfo.r. So that's what is inside my file. So if you can create this file, sessioninfo.r, and run it using R script sessioninfo.r and get some sort of output like this, then please put a tick next to your name. I see we've currently got 2 people with ticks.
Mine
Okay.
says command
Yeah.
not found.
Yes. So I'm now the thing is that if you have downloaded R in your normal Windows and then you try and access it using Bash and it doesn't see our script at all, then we might have a problem. So maybe just try and run R script without the name of the file in front. So you should get some sort of something like this. If you don't, then it means that R is not installed or cannot be seen by the terminal that you're working on.
I think it's not seeing it because I'm getting the same error.
Okay. Yeah, this is what I was wondering if this was going to happen uh with R. Right. I'm going to see now. How did they ask it to be installed? Feel like what we're going to have to do is make sure that you can see CR in the pathing. So, now I'm trying to remember in Windows how this works. If anyone who uses Windows or Mac has any ideas, you're also welcome to put it in the chat. Let's see if I can look this up. So we're having a problem. So git for. Yeah, so R script isn't on your path that git bash can see. So yeah, if you can't see that, okay. You're going to have to work out where you installed R script. So you're going to have to look in your program files, look for R, your version, go into bin and then find your script. So what you're going to probably have to do is add R to your Windows path. So there's like this environment variables place that you can search for on Windows. So if you go in the search bar, environment, there'll be something like edit the system environment variables, control panel. Then you'll have to go click on environment variables and add in a new system variable. And then put in the path that you have to where you have R. So you're probably going to get something, you're going to have something like C program files R and then R. So for me it would be 4.5.0/bin. You'll probably find a path, something like that. And you'll need to add that path into your environment variables and then restart your terminal and try and run our script version. If you've added in the path, so it basically what's happening at the moment is you have R installed on your machine, but only certain things can see that program. So when you try and use it with git bash, it doesn't know where to find your R. So it gives you couldn't see that command. So that's why you have to change your environment variables in Windows so that it tells all other programs where your path to R is so it can run things like R script. So it's basically your current terminal can't see what software you're trying to use, where that is in your path. But let's see if that helps. I see we only have one, two, three people who've managed to see the R script part working. Is everyone else having the same issues? No, I've got 4. Okay, ongezwa, error in session info. Could not find function. Okay, ongezwa, your info, the I isn't capitalized and you don't have the function, like the round brackets afterwards. So that's why it's saying, I don't know what, it can't find that. So if I show you what's here, I've put session, then capital I for info, and then open close round brackets. So if you change it to that inside your R script, it should hopefully run. Okay, I'm just thinking this. We might run out of time if we're going to try and get this to work on everyone's terminals. I'm not sure because it might take like another 15 to 20 minutes just to get a few more people ready to begin this part. So I'm not sure whether maybe if we skip over this episode and go to the next one, it might actually be easier and it's not um, gonna waste everyone's time waiting and trying to sort out how this would work on Bash. I'm not sure. Rahima, do you have any thoughts on this?
So I think the issue here is the different OSs and how the
Yeah, how it all works.
Mhm. And in the chats, there are few people who are still are not able to switch between the different directories from the command line because, well, the the issues with the Windows people and some people have not yet still been able to get comfortable with switching directories or navigating the file system
Yeah,
properly.
yeah.
So I think it's best if we go to to the next episode that include doesn't need us to use the command line. I think it's a shorter episode and we can manage to take it through the remaining time.
Yeah, because there's a lot of coding that
Okay.
happens in this episode, so it's good if we
Mhm.
get people to code at the same time. So yeah, I'm not sure if we would really get much out of the session if I
Yeah.
just coded and everyone watched because it might not. I mean, everything that I would show is already talked about in detail and gives all the outputs in the carpentries section. So uh, maybe the only thing that I will highlight here at the moment is you can run we've been using RStudio where we're running our R scripts inside RStudio. You don't have to do that. You can use a terminal to run some scripts, especially this would be useful if, for example, you have access to a high performance cluster. So you're working on a server and you can't open RStudio necessarily on this international or national resource. So what you would do is you would basically create um, a script which ends in .r, which has all the commands that you wanted to run. It will have things like it will save your outputs to files and folders. And then what you can do is you can run it on the service on that like high performance cluster, or like here for us, it would be on my local machine. But if you're wanting to work with the data and see like the global variables and see the plots as they come up, RStudio is a much nicer interface to see all those things happening. So um, in the terminal, it's great when you have a whole lot of intensive things that you need to do. You don't need to see what you're working with at the time. Yes, Rahima.
Hi, Emily. Thank you very much.
Hi.
Just a weird question. When you're using the command line interface and you're generating a script, do you have to use like the weird R language? I don't know if that's the right word. Does it have to match R? So I'm using Ubuntu and I think Python seems to be a little bit easier for me. R seems just very weird. So,
Same, same. Because I was actually looking forward to us moving to the terminal. So it's just bad
yeah.
that others cannot. Because for me, it's easier to navigate things on the terminal than on Art Studio.
Okay, yes. So when you're working with RStudio, it's basically called a graphical user interface. So you can do a whole lot of things by clicking, by just running code one at a time. Whereas if you're creating, you could in RStudio go and write up your R code, right? Because we've been writing all of our lines in script.r. The only thing that's going to be different is that we were running those commands one line at a time by doing Control Enter. Whereas when you create a script and are going to run it on the command line, you're going to have to make sure that everything is doing it in the order you want. So you need to make sure that all the lines, if you run it line by line, it does what you want. Um, and you need to make sure that you're going to save things that you want to keep to files and things. Um, R can also be a bit different. Like I know if you use Python, and Python is my like first language for computers, so I'm more used to all the syntax and everything with Python. And you also have some nice things where you can just use Python. I'm more used to Python, so I can write the code faster in Python, but R has its own way of calculating things. Sometimes R will be faster, sometimes Python will be faster. It depends. Maybe there's some packages in R that you would never get in Python, so that's why you have to then use R. It's very much a case of you will need to discover what sort of tools you need to do for the job you are trying to do, whether that's data science or anything else. But I mean, R is the same. Like here, I'm saying R script, and then session. So here I'm saying use the R interpreter and execute this code for me. The same thing would happen with other programming languages. Like if I made a Python script, I could do something like I would write Python here, and then whatever my script is, like abc.py, and the same thing would happen. It's just there's different ways of executing your code. Um, so for us,
Okay.
I think the easiest is just keeping on working with RStudio, but know that there is a way in the terminal to run this.
Just a quick question before we close. When we
Yeah.
were working on Art Studio, right? We could
Yes.
run a command at a time, right?
Yes. Yes.
Without having, yes. Can I do the same on the terminal, or would I strictly have to finish up my script first, then run it with R script? Can't I be able to confirm? You know how
Um,
with
yeah, so
Bash you're
line,
able to write a script, yes, but you can also run a line on your terminal without actually having to write the script.
so our script is where you have a full script and you ask it to run. But I think there's something called R where it basically you see what we had in the console in RStudio, it brings up the same thing.
Okay,
So I could do something
yes.
like num
Mm,
is like
okay. Oh, so you
so
can call that, okay,
so
the
yeah,
console
you
using R.
can
Okay,
R, yes.
all
And
right.
then for
Okay,
us, if you want to run a script, instead of calling R, you call R script and then the full script name.
okay, I see.
So
Thank
scripts
you.
come in when you want to run some like very specific set of things. Like I don't know. I can think in maybe my field. Um, Rahima and I work in bioinformatics, so we look at proteins, and let's say we've run this long simulation, and we want to see what happens at every time period calculate a whole lot of things, we would not want to try and run that script on our computer because it's so intensive. Like we work with files that are like, I don't know, can be up to like 50 gigabytes in size. Um, so we don't necessarily want to be working on those huge files on our laptop. So what we would do is we would create the script knowing what we want to do to calculate the things we need to calculate from those really big data files. And then what we do is we send it up to our server, and then we say, okay, now in the command line, because we can't use RStudio, for example, in our server, we'd have to use something like RScript and then the name of the script, and it would do all the processes that we needed to do, not on our laptop. So it's not using all of our memory and compute resources, so we can get on with other things while that script is running for, the 10 hours that it would take to calculate everything. So there's different uses, RStudio is great when you want to be doing things one line at a time, working out how to create the script. And then the terminal is great when you have a fully made script that's ready and you want to just run it and let it go carry on in the background, either on your laptop or on a server that you have access to, which has R installed on it. Does that sort of make sense?
Yes, but one last, I don't know, dumb
Yeah,
question
yeah.
before we
No,
close
no, no.
this part. Well, I saw that we can use R script to run a script, right? And then we
Yes.
can use R so that we have access to its console, right?
Yes.
But now, I'm trying to think through like when you begin, as we began here, there was a bit of clicking when we're creating our projects. I think so. When we move to the terminal, would I have to go into R console and then create my project? I'm trying to I'm trying to link that to like then what we've been doing on our console when
Okay.
I move to the terminal, for example. Also
So
like would I have to
yeah.
CD using my on my terminal, just change into the right directories first and then create all or make all the directories that I need here first and then move to the R console on the terminal. How would I work around that?
Okay, I will answer your question like now. I see Jason asked for the R session info.r. Which part? The part where you run it or where you make it?
Hi, Emily, if you speak. It's easier from the beginning
So where we
part where
made
you
it.
make it first,
Yeah,
yes.
I used Nano.
And yes, okay.
Yeah,
Thank you.
sure. Okay, so when we did RStudio, we created a project. So projects are very useful for RStudio as like the GUI, like working with RStudio and not R. So for that, a project is basically saying, whenever I open up RStudio, I'm going to be working in this path, and I want you to save everything that I've been doing. So that doesn't mean just save the R script. It means please save all the global variables that I had. So when I've executed the code that I've run, it keeps stuff in memory. And so when you have like the project and the session, it asks you if you want to save it. And I say yes, because when I open up RStudio again, I want to go exactly to where I was before. So I don't want to have to go to the top of the script and press Control Enter until I've got all my variables back in the environment space. Whereas when we're working with the script, what's going to happen is most likely you're just going to have at the top of that script, you're going to be running every line of code in that script anyway. So you're going to be reinstantiating, reassigning all those values to the variables that you have. So you don't necessarily need a project open for R or R script to work in your terminal. I just moved to where we were working with R because I want to keep all of my R scripts in general together. So you didn't have to go into R novice inflammation and run the R script inside there for it to be able to work. I could go to my documents or make a new folder somewhere completely different and run R or R script again. You don't need a session or a project open to run R or R script. The only thing that we were doing, the project creation for our studio, is so that we could actually keep and save everything associated with what we were doing in our studio over time. Does that sort of make sense?
Yes,
Or
with the script, it does. But I'm talking about when we're using the R console on the terminal.
the R console just opens up a completely new R console. It's not gonna remember anything from a previous session unless you ask it to open a session, I think. So if I've closed, so it says, do you want to save your workspace image at the bottom here? I think you could say, so let me do the same thing. So if I try and run num now, I said before, save workspace image, I said no. So if I try and run num now, it says I don't have a variable called num. So let's assign 37 to num, right? So we have 37 there. And now I'm going to quit. So you write Q and then those double.
Yes.
Yeah. And then they say, do you want to save the workspace image? Let me try and say yes. Okay. Now if I look, hopefully it has saved my workspace. So if I now open up R again, it tells me my saved workspace is restored, and let's see whether it remembers what num is. It does.
Okay. Right.
Okay.
So it's important to then save your workspace.
Yeah, so it will ask you when you quit, do you want to save your workspace? You can say yes or no.
Okay.
Yeah.
Oh,
I'm
thank
going
you.
to say no. Okay, great. Right. I think the best thing to do now, okay, I'm going to get if you would like to try the command line thing yourself, the episode, I'm gonna get the link for you to see how you could go about doing the commands that they have there. So let me just get there. So it's episode 5. It's called Command Line Programs. So yeah, there we go. But remember, you can always search programming in R, software carpentry on the internet, and it should take you to this site. And then you can go and look at all the different exercises and parts that they show. Okay, but I'm going to go on to the 6th episode, which is best practices for writing R code. So I'm going to just open RStudio again. Okay, let me stop share. And then our studio. And then I need to open my script.r. Okay. Right. So best practices are going to be very useful if you are coding, especially with other people. And also if you're ever going to publish any articles or any of your information and you did analysis using R, it's very important that you know how to keep track of things like who wrote the code, when did you write the code, what's the purpose of the code, so that others who look at your code or you who look at your code later can remember what was going on. And also reviewers might want to see some of your analysis code to make sure that it's looking correct, especially if they feel that something does not look how they would expect it to look. So at the top of a file, you'll often have some sort of comment. So they give an example like this is code to replicate the analyses and figures from my 2014 science paper. This is the example that the Carpentries give. And then code developed by Sarah Supp, Tracy Teal, and John Borelli. Also, sort of depends on what field you're working in. Sometimes you'll have something like your email address if you want people to get in contact with you to ask questions about the code you've run. You might have a date or developed, and then you have the date that you created this, especially if you make many, many different scripts. It's sometimes nice to have an associated date with when you started developing stuff in the script, so you sort of know when you were making this. But again, this depends. But it's good to say what the script is doing, what the code is doing, and who made it. It's very important to give credit to everyone who helped in creating the code. Just like how it's important to give credit to people who were involved with articles and such. You do not want to say this was all your own work if it was not all your own work. At this point, you can also start version controlling. So, okay, I've created this new file. We're going to be doing XYZ inside this file. Now I want to put it up on Git so that you can regularly save and have versions of it. So if something breaks when you try to add a new feature, you can just go back to the old version and try again, etc. Then another thing that is very important is to make sure that people know exactly what they need to install to be able to run the code. So it can be very difficult if someone's finds your code and goes, yay, I can run this code. And then they try and run it. And then there's a whole lot of things where the code gives up errors because they don't have certain things installed that they need to be able to run your code. So what we normally do is if you are including anything new that isn't built in, then it's good to put all of these packages or dependencies that you have and their installation right at the top of the script that you have. So you might see things like library, ggplot2. Some people like using this package to plot certain types of plots, especially in for statistical things like QQ plots and such. So you'll have a list of all the libraries that you want installed and put that right at the top of your R code, because you don't want to suddenly see these libraries like right at the bottom. Like, okay, I'd spent 2 hours running the script, I'd got to this part, and then suddenly it throws an error because I hadn't installed a package. That can get very frustrating for people. So try and make sure that all of your imports or, installing your libraries and packages happen right at the top so that people can make sure everything is working before they run your script. Another thing to try and remember is that it is good to not try and repeat certain strings or bits of information that could be changed later on, and then you'd have to go and search for every single place where that string that you had written in is now changed to a different thing. So let me give you an example. So we can have something like input data, and we say, I want to read in from a CSV file called data.csv, and my sample number is the number of samples in a row from input data. So that's all fine. So we want to get number of samples in data. And then we want to generate results. So our results will be, we'll have some function. So this isn't going to run, right? Because we haven't defined some function. But let's say we say one of the inputs that's required is the name of the file and then the sample number. And then we want to write results. So we say write.table, data, results.csv, output file. So let's say you made a mistake and this file is not called data.csv. Maybe it's called data_1.csv. Now, if you changed this data to data01.csv, if you ran this code, you would get into trouble here because you're giving it not the same name here anymore. And you'd have to go control find and search every place where you had data, the original string, and fix it. So that can take a lot of time if you've used this string somewhere many times. So it's much better practice at the start to say, these are all the variables that I have at the start, and then only use variables after that. So for example, input file is, we can do data.csv, and an output file is data results.csv. Then we can read input, where we have input data is read CSV input file. Then get sample number in data would be sample number in row. So find the number of things in the row, input data, and then generate results. So results is some other some function with an input file and sample number and write results. We have write.table results output file. So if you look in this code block, there's not a single time that we have our strings. All of that is defined at the top. So if, for example, one of these niche names changes and we say data01 here, then we are sure that wherever we are now, we had data.csv, we now can work with data01.csv and nothing breaks. So it's good practice to try and put a whole lot of these variables that you know you're going to be working with a lot up at the top and keep referring to them by variable name and not rewriting the string or the number or whatever in your code. That's what's called hard coding sometimes. You might have heard of that term. So if you hard code in a string, you then have to go and find every place where you had that string and change it to the new value of what it should be if there was a problem. So try and get in the habit of instead providing these values to variables, and then you just call the variable wherever you need that string because it makes it so much easier to change things if there is a difference that suddenly happens with like a name or something. It's gonna, yeah, it may be slightly longer at the beginning, but it will make your life a lot easier when you are making changes later on. And sometimes you'll get an error and wonder, why do I keep getting this error? I've looked at my code, it's all correct. And then you find that in 100 places where you call data01.csv, there's one place where you had data.csv. And that was the whole reason why your whole long script didn't work in the end. And it can be nice. So let's say you have three main sections that you're working on. So let's say you have a section where you are importing files and cleaning datasets. It's nice to have in your code something like a comment where you have section 1, and then you have that part, and then you have all of your code, and then you have section 2, and then you can say analyzing data through XYZ plots, and then you can have all of that code. It's basically like nicely putting sections that you're working with together in parts of the file and just having the comments there so that you can work out where you are, in what part you're working in. It can be quite useful to just, yeah. So, and often the best practice as well is if you've got functions, define function 1 here, function 2 there, and function 3 there, and then you can use all your functions lower. That's what most software or coders will try and do. I mean, you could do some lines of code and then you have your first function and then use it and then have some more lines of code and then suddenly have a definition for another function. I mean, it's just best practice to try and put all of your functions together for a certain section in one place and then put all your lines of code where you refer to your functions below that. Again, though, this comes with practice and just also reading other people's code. although not all the time. There are plenty of professionals who do not stick to best practices, especially if you're on a time crunch and you do not always neatly document all your code. But it is good to try and get in the habit of doing that. Same with variable names. It's good to try and stick to one thing. Like I like using underscores between values. So you don't necessarily want to say variable number one because that's a long thing to type out. And each time you use that variable name, it's not going to be, you're going to spend time doing it. So that's why we often will shorten words, but still try and remember what those shortened words mean. So for var, for us, var is usually means variable, or num usually means number. So there's a lot of these sort of things that you get used to, but you might have your own system of how you shorten things and how you remember what you're talking about. So I use num and then an underscore and then one so that I know that I'm separating by name. So there's other ways of doing this. So you could do something like num1, but other coders might, so I like separating by underscore. Other coders might prefer camel case, and that's where you don't put an underscore and then you start every new part of a word, every new word with a capital here. So this is called camel case. So you might have your style, and then it's best to stick to one. So if you're going to be using underscores between words in a variable name, then try and stick to just always using underscores. If you want to use camel case, then try and stick to using camel case every time because then it starts getting tricky to remember, hey, wait, did I make it as num underscore one or did I use the camel case num one? So those sort of things, you're basically trying to um, reduce the amount of time you will take trying to code things by sticking to like specific rules that you have decided you're going to stick to and that many other coders before you have stuck to. And it could reduce your coding session from 5 hours to 3 hours if you try and stick to these sort of best practices. Yeah. Okay. We have, here we go. R can run into memory issues. It's a common problem to run out of memory when you've been running scripts for a very long time. So you can try and look at what packages you currently have installed, because if you have a very big package, it could be taking up a lot of your memory and you might not need it installed anymore. So you can try and remove it. So R tries to do this for you, but it doesn't always. So if there's this there's a function called GC that I believe stands for garbage collector. You can run this yourself. So R tries to do this behind your back and try and like take back any memory when it thinks you don't need that memory anymore. But you can run it yourself if there's a problem. So yeah. So this says if you're using anything you don't need anymore, please remove what you don't need from the memory so we get more memory to keep working with. And then they say it's best practice sometimes to not save session history. So sometimes what you want to do is start in a new clean environment. So when we've been working, we've been keeping all of our stuff in our global environment, right? So with our examples, we're okay. We're still managing with the sort of memory we have. but sometimes it's best to just not keep the session history so that you can then go and just run the parts of the code that you want again. Also, it can cause problems where, let's say, you have dat here and you haven't realized that you went and ran something, another line of code, which also gave assigned dat a new variable, and then you're suddenly working with data that you weren't expecting to have worked with. So sometimes saving what you've previously done is not always a good thing. But again, leave that up to your discretion as to whether you are finding the session history useful or not. And then if you use session info, what we saw before, that can be very useful. Have a look and see what packages you're using, because it at the end tells you which packages you have installed. So, and also the version. So sometimes you might have run the script, and then 2 years later you try and run the script, and you can't run the script, and turns out that the package that you were using has been updated and they've changed the functions that you used, so they no longer work in your code. So you can go and reinstall the older version of that package so that your code still works. And the last thing that they say is collaboration is very good. You can go and find someone else and make sure, like, if someone else does coding, you can go and say, here's my code. What do you think about it? Do you want to try using my code? How well does it work for you? Sort of get feedback and collaborate with other people and see if you can improve your code that you have written based on what other people think about it as well. So you might have a friend who says, yes, this is such a nice piece of code. The only thing is that I wish it could do X, Y, Z. And then you can say, oh, that's a great idea. Let me code that bit in as well so it's more generalizable, and all these people in these areas can also use what I've coded up. So yeah, it's good to try and keep best practices. And yeah, I think that's most of those tips. And I see, oh, we're already at 1 o'clock. Okay. Thank you everyone for staying for 5 days. I'm sure there was a lot of new information, and I know we've been having some issues, but thank you for sticking and coming. And yeah, I hope you have learned something from each of the modules, maybe shell or git or some R, and maybe you feel a little more comfortable or ready to try and use some of this in your own research, or if you're going to be going into the industry, maybe you'll be more prepared to try and do some coding yourself. Yeah, so thank you all for coming for these days. It's very nice to see you all, and I'm glad that there are people who are interested in these sorts of topics, and I think it's very useful for people to know some coding. And I also want to say thank you very much to Rahima, who instructed on the first day and has been answering all your questions, and Takudzwa as well for the questions that he's been answering. Yeah, so I just hope that everyone had a good 5 days and you've learned something. And yeah, I think what happens is you might be asked to fill in a post-workshop survey so we can sort of know, how did the days go? Did you learn from it? Was the pace too fast, too slow? What can we improve for the next time we run these courses? Yeah, so thank you, everyone. Rahima, anything to add?
I have nothing to add. Thank you again all for showing up and asking the questions.
Yes.
I think the learning has been both ways.
Yes, we've
Because
learned a lot.
the more you teach, the more the things also start getting you start also getting to understand them more as you teach them. So I think this has been we've been learning both ways, and I'm happy that you're asking the questions, engaging in the chat. And there's no stupid question. One last thing. I don't know if I discovered something that you can actually attach a file from Zoom. I don't know if Emily, you can try. There's a small box. There's a small box in the chat. I don't know if the Emily script can be helpful to you if you wanna practice with it. But in the chats, there's a small box that one can attach a file, if I'm not wrong. If
I'll
Emily, you
see
can try
now.
maybe send them your script.
Ah, okay, okay.
Mm.
Hopefully it doesn't oh, but it's in Zoom itself. Okay, here, okay. Desktop, novice information. I'm gonna share my script.r file.
Yeah, just in case they need to practice and maybe compare what they've been having.
Yeah, okay, it should be
Then
sent.
then they need to download it and then before the session ends, of course, because it's gonna
Yes.
disappear.
Yeah. Are you seeing it? Or has nothing come through? It should be
Okay.
script.r. Yeah, okay, yeah, someone sees it. Yeah,
Okay. All the best with all your endeavors. Happy coding.
still have trouble downloading. So there should be like a little arrow. Yeah, so it says potential security issue detected for me. So just say download anyway, and then just save wherever. It'll probably take you to downloads. Yeah.
Well, I'm having trouble downloading it.
Okay.
What is the issue?
It just doesn't give me the. Okay, initially I could click download, right? Now I can't.
Mm.
There's just this red exclamation mark with red white whatever. Red circle with the white exclamation mark.
I think it's still
Um,
the security issue.
yeah, it's a security thing.
Well, we can have Tutukile share it with you together with the because she's supposed to send you the links to the recordings. We can have her send the script with
Script in the
you
email.
together
Yeah.
with the yeah, sure.
Okay.
Okay, sure.
Okay. I hope we are free to reach out at any time in the future. I'm not sure. If you send an email, it really depends. Some of us are about to get really, really busy this next month. So, um, I mean, you can, I can't guarantee that we'll be able to respond even like within a day or two. Like, it might. Yeah, unfortunately, we are doing our own PhDs, so we have our own set of work that is quite time sensitive. But if you want, you can send. I can't promise that we will immediately respond, but yeah.
Yeah, I concur with Emily on that. But we will try respond to you when we have the time, when we are able to. Just
Yeah,
don't feel shy to reach out.
yeah.
Mm.
Okay. Any more questions? Yeah. I don't see anyone else. Right. I think at this point, all I can say is I hope you enjoyed this and I hope you got something out of it, and all the best for all your future studying or work or whatever it is that you are continuing with.
Thank you very much.
Thank you.
Thank you so much.
Sure.